Welcome back. Now let's summarize the KNN pros and cons. First, we have the pros, right? Let's discuss the pros. The first advantage of using KNN is that it's very easy to explain, simple to understand, and extremely powerful. So if you are working with non-technical people and you want to make them understand what you are doing and justify why you are using this algorithm and not the other ones, then KNN is the best one, right? Because it's very easy to explain to any people in the world, right? It's very, very easy. The second advantage of using KNN is that it doesn't require any assumption on the data distribution. And we saw this before and emphasized this point many times, right? It's the first choice when there is no prior knowledge or very little knowledge about the data distribution. So if you are not really sure about the data distribution, because as we will see, some machine learning models are sensitive to the data distribution, right? So you need to have a deep understanding of the data distribution or some prior knowledge for the data. It's always useful to have some prior knowledge of the data, but if you don't really have any knowledge and you cannot have any knowledge, then maybe KNN will be your first choice. And it can also be used for regression and classification problems. And this is a huge plus for the KNN, because for other algorithms or some of the other algorithms, we will see that it's very, very hard to change this algorithm or modify this algorithm to work with regression or to work with classification. So it's only working on regression problems or it's only working on classification problems, right? It's very, very hard sometimes to modify the algorithm to work on both classification and regression. And KNN is very, very easy to do. So you might ask me how we can do so, how we can change the majority voting to be something else. Basically, instead of just taking the majority voting, you will take the average. So you have everything as it is, you will just change majority voting to be average voting. And that's it. You have a regression KNN. Okay? And finally, it can be used with multi-class datasets. So we saw this in the Stanford demo, right? We saw that we can have more than one class. We can have 2 classes. We can have 3 classes. The iris dataset, in fact, has 3 classes, right? It's not a binary classification problem. So we used KNN with no problems. We didn't really need to do any modification on the code, right? Some other algorithms are only working for binary classification datasets. So it's very, very hard then to change the implementation of the algorithm in order to work with multi-class datasets. And as we saw, KNN can be used with multi-class datasets. So this is also a huge plus for KNN. Now, let's talk about the cons, right? The first problem with the KNN is that the efficiency of the algorithm declines very fast as the dataset grows, right? It's an exponential decline. And we saw this before, right? We saw this when we were talking about the curse of dimensionality. And this comes at a cost of making the prediction step relatively expensive. So what comes at a cost? Not knowing anything about the data, or we don't really make any assumptions about the data distribution, this comes at a cost of making the prediction step relatively expensive. Because every time a prediction is to be made, it searches for the nearest neighbor in the entire dataset. The third problem with KNN is that it suffers from skewed class distribution. So what does this mean? It means that if a specific class occurs frequently in the training data, then it's most likely to dominate the majority voting of the new examples, right? And we didn't really have this problem when we were working on the iris dataset because we had 3 classes and each of them shared equally, right? So we had 50 examples from the first class, 50 examples from the second class, and 50 examples from the last class. But sometimes in real world datasets, you can find that you have 80% of the data from the first class and then the other 20% are distributed on all the other classes. So this can be a huge problem for the KNN. And finally, the KNN algorithm will not work if we have any missing data, because the KNN algorithm relies on calculating the distance between the test point and all the data, all the training data. So if we have any missing value, then the code will stop and will throw an error in your face. For other algorithms, or for some other algorithms, you will find that if we have missing data, it will not be that much of a problem. Okay, so this can be a problem for KNN. So this is basically the pros and the cons of the KNN. In the next lesson, we will start working on the KNN project. So let's go.